All right, let's see how the sound works on this one now, okay? I think I debugged the sound on the last couple videos. Sorry about that. I think it was picking up the sound on the Elmo instead of my MacBook Air, which has a better microphone. Let's see how this works. Welcome to Tuesday, the second day of the second semester, the second day of the third quarter, the second day of school for 2021. You guys are going to rock this year, aren't you? Right? Okay, go ahead. Copy this down. Go try it. Come back and see how you did or get some help if you need it. Okay? We'll see you in a bit. There's my red pen. Okay, diamonds first, right? 35 and 12. What two numbers have a product? You multiply and get 35 and a sum of 12. You add them, you get 12. What works there? Well, 7 times 5 and 5 times 7. Right? 7 plus 5 and 5 plus 7. Remember, that's commutative. Addition and multiplication are commutative. Doesn't matter the order. How about 28 and 11? You got that one? 5 or 4 and 7 on that one. 24 and 11. No 7s on that one, huh? 3 and 8 work though, huh? And how about 72 and 17? Good job. 8 times 9. Okay, remember how to do the prime factorization? First, what we do is do a factor tree. And again, what you're doing is you're trying to find out what numbers multiply together to equal that number. And for 62, I know it's even, so I know 2 will go into it. I can't think of anything else. And multiplying something by 2, if you want to find out 2 times what, you just cut it in half, right? So 2 times 31, and this is how we make our factor tree, right? Now, when I get to the 2, the only numbers that go into 2 are 2 and 1. And I wouldn't say 2 and 1 because then you'd do 2 and 1 again with this one, and it would go on forever. When you get to a number that only 1 and itself go into it, you circle it. That's called a prime number. Now, 2 is a special prime number. Do you know why? Well, there's 2 reasons to make it special. One is it's the smallest prime number. 1 is neither prime nor composite, remember? And the other reason it's special, it's the only prime number that's even. Right? Why? Because 2 goes into every other even number. Right? So that would mean that the other number would not be prime. All right. 31 is also prime. If you weren't sure of that, you'd check to see if 2 goes into it, then you check 3. There's a trick to see if 3 goes into a number. You add the digits. 3 plus 1 is 4. 3 didn't go into 4, right? I don't have to check 4. I'm only checking prime numbers. I do check 5. Now, the trick with 5 is it ends in a 5 or a 0. 5 goes into it. This ends in a 1, so 5 does not. Now, do I have to keep checking all the numbers up to 31? No, I check prime numbers until I get to a number times itself is bigger than that. So 5 times 5 was 25. 7 times 7 is 49. So once I check 7, I'm done. And 7 times 4 is 28. 7 times 5 is 35. So that doesn't fit. So I know that that's prime. I circle it. Once you have made a factor tree, you take those numbers that are circled at the bottom of your factor tree and you put them in order. Now, these are already in order, but if I did 31 times 2, for the prime factorization, I would put the 2 first. Okay? That's the prime factorization of 62 is 2 times 31. Okay? How about 63? No, a lot of people were saying that's 7 times 9, right? When 7 is prime, how about the 9? The 9 is not, right? Because you can go 3 times 3. Now the 3's are, and remember what I said when I made the prime factorization, I've got to put these in order. So these 3's are going to happen before the 7. 3 times 3 times 7. Now you can, if you want, after you put them in order, it ends up grouping the numbers that are the same. So, and you can rewrite those numbers with exponents. So 3 times 3 is the same as 3 squared, or 3 to the second power, times 7. Okay, and again, practice learning how to say this. The prime factorization of 63 in exponential form is 3 squared times 7. Right? Have fun with that when mom says, what'd you learn today? Remember, don't say, nothing. Say, I learned the prime factorization of 63 in exponential form is 3 squared times 7. Yeah, don't say it while she's driving, though. All right. 8 times 8 fell on the floor. I picked it up. It was 64. 8 is the same as 4 times 2 or 2 times 4. The 4s, I'm going to have a 2 times 2, but the 2s I'm going to circle. Whoa, look at all that. 64 can be written as a factor of 2s. How many 2s? 1, 2, 3, 4, 5, 6. So I can simplify that and use exponents and write 2 to the 6th power. Boom. Right? All right, 65. I know 5 goes into it how many times? Well, 5 times 12 is 60. 5 times 13, those are prime. Boom, 5 times 13 is your prime factorization. All right, remember how the absolute value works? It is how far is that number from 0? A lot of people just think of it as being a positive number, no matter if it's negative or positive. The absolute value of -3 is 3, because -3 is 3 spots from 0. The absolute value of +3 is also 3, because that's also 3 spots from 0. Okay, now 5 minus 2 is 3. 2 minus 5 is -3, but its absolute value, same thing, right? So when we're talking absolute value of 5 minus 2, it's the same as the absolute value of 2 minus 5. Kind of cool, huh? This ends up helping you when you do exponents, especially with fractions and decimals. Okay, you'll see that later. Now, the absolute value of 8 minus the absolute value of 3 is 8 minus 3. The absolute value of -8 minus the absolute value of -3, again, that's 8. That's 3, so that's 5. Now, these are not absolute value problems. These are just integer problems. I wanted you to practice. You have 10 plus you owe 3. You're going to pay that 3, and you will still have 7. Now, remember, if you are subtracting with integers, a lot of kids have told me in the past that it's much, much simpler and less confusing if they change all of the subtraction problems into adding the opposite, because you're allowed to do that. Now, this -10 stays as -10. Don't change that one. But instead of subtracting -3, I'm going to add 3. Now, be careful. Stop, take a breath, chill. Don't just go straight and say, oh, that's -13, right? I owe 10, plus I have 3. I'm going to pay the 3 I have, and now I'm only going to owe 7. Okay, that was the hardest one in the bunch so far. Okay, remember how to do the generic rectangles? 32 and 45. 40 and 5. 30 and 2. And here we go, 3 times 4 is 12, but I have 2 more zeros. 3 times 5 is 15 with a 0. 2 times 40 is 80, and 2 times 5 is 10. Now I come over here and I add those. And what do you get? 13, 14, 4, 1,440. And then I always like to, because I like math anyway, just make sure I got this right. 2 times 45 is 90. Put a placeholder, because that's really a 30, right? 3 times 5 is 15. Carry the 1. And 12 and 1 is 13. And I get the same answer, so I feel good about that, right? Double checked. Now, this is kind of cool. This is one of the reasons I like that we teach the generic rectangle. I didn't used to do that, okay? And I think that's a kind of a cool way sometimes to multiply mixed numbers, okay? 6 times 3 is 18. 3 times 1/2 is 3/2, right? Because 3 is the same as 3 over 1. And remember, multiplying fractions is easy. You go straight across the top, straight across the bottom. So that's 3/2. 2 times 6 is 12. So this is 12/5. And 2/5 times 1/2. 2 on top, 10 on the bottom. Now, 2 on top, 10 on the bottom. Now, I have 18 and 3/2 plus 2/10 plus 12/5. Now, I have different denominators. Remember, when you add fractions, you need the same denominator. Now, all three of these numbers go into tenths. So I'm going to change these to tenths. 2/10 stays 2/10. But I do 2 times 5 on this one to get to tenths. I got to go 3 times 5. Now that looks weird, huh? Well, it's improper. That's why. That's all right. I did 5 times 2 to get tenths. I got to go 12 times 2. 12 times 2 is 24. And now I'm adding the tops. 15 plus 2 more is 17, plus 24 is 41/10. So 18 and 41/10. Well, 41/10, divide the bottom into the top. That goes 4 times, and that's 40. And my remainder goes on top, divisor on the bottom. So that is the same as 4 and 1/10. 18 and 4 and 1/10 is 22 and 1/10. Now, how many people got that right? Yeah. Now, how I used to teach that, 6.5 times 3 2/5. I used to teach this by making these improper fractions using what's called the C method. Now, see how I made that C and I did from the bottom up? 2 times 6 is 12 plus 1 is 13 halves. 6.5 is the same as 13 halves. And 5 times 3 plus 2 is 17/5. 3 2/5 is the same as 17/5. And then I'd multiply 2 times 5. That's easy on the bottom. But then 17 times 13 on top. Okay, I'm going to try to do this in my head. 17 times 10 is 170. 17 times 3 is 51. That's 221. And then divide the bottom into the top. And some people are saying, wow, that looks kind of hard, Mr. Daniel. Right? That goes in. And then I have 21. And I'm going to say another 2 times. That's 20. And remember, your remainder goes on top. Divisor, number outside the box, goes on the bottom. 22 and 1/10. 22 and 1/10. Like to double check, right? All right. Have a great Tuesday, everybody. Don't forget, try to challenge yourself to ask your teacher a question on how to do something, okay? That will make you a more mature student, okay? And if you force it on something that you might already know, then you're not that nervous about asking about something you don't know, right? Okay, it's good practice. It's exercise for your student skills, right? You want to exercise everything. All right, have a great Tuesday, everybody.